Hello, I'm here today to help you solve the following problem. Let vector v of t equal the vector t squared, comma, sine t minus t cosine t, comma, cosine t plus t sine t be a velocity vector. Find v double prime of t and the position vector r of t. So, to solve for this problem, we're going to need to be well accustomed to derivatives and to integrals. So, in order to find a double prime of v, we must first find the first prime of v. However, let's start by writing out what vector v is, just to have as a reference when we're working on the derivatives. So vector v, according to the problem, is t squared, comma, sine t minus t cosine of t, comma, cosine t plus t sine of t. Okay, so let's take the derivative. Find the first prime of v, so we can solve for the second prime later on. So, as we all know, the derivative of t squared would just be 2t. Now, to find the derivative of sine t, we have to know that the derivative of sine is a positive cosine. And we multiply by the inside, but since the SN is just t, that'll just be 1, so it doesn't change the quantity. Minus. So here we have t times cosine of t. We have a product to the right, so we gotta use product rule. So product rule states that we keep the first quantity as it is, and we divide the second. So the derivative of cosine would be a negative sine of t. Now we add, and we take the derivative of the first one, which would just be 1, and we keep the second one as is. It would just be cosine of t, comma, the derivative of cosine of t again, which we know is negative sine of t, plus, here we have another product rule, so let's tackle it as we did the last one. We have t times the derivative of the second, which would be just cosine of t, plus the derivative of the first, which would be 1. So we're left with just the sine of t. Okay. As you can see, there are things that we could potentially cancel out. So let's go ahead and rewrite it so we can better see what we can and can't cancel out. Let me rewrite this here. So we're gonna have v of tt, comma, cosine t plus distributing the negative into the parentheses, plus t sine of t minus cosine of t, comma, negative sine t plus t cosine t plus sine of t. So here we can see that we can cancel out this cosine with this cosine and this sine with this sine. What are we left with? Well, let's rewrite it. It's always nice to keep organized when working with calculus, as this organization can make this already complicated mess that much more complicated. So we have vector 2t, and here we're just left with a t sine of t, and here we're just left with a t cosine of t. Okay, nice little vector we reduced. So now let's find v double prime. Take the second derivative. Okay, so we know that the derivative of tt will simply just be 2. Now we have a product rule, so let's do this as we have before. We have t times the derivative of the second would be cosine t. And then we add the derivative of the first, which should be 1 times sine of t. So it would just be sine t. Do the same thing for this following problem. We'll get negative t sine t plus the derivative of the first, be 1. So we're left with just cosine t. And this, ladies and gentlemen, would be your vector double prime t. This would be the first part, the first answer of this question. Now, to solve for the position vector, when we're given a velocity vector, we must take the integral of the velocity vector. So, let's do that. The integral vector t. So to do this, we must take the integrals of everything on the inside. So, t squared, the integral of sine t minus t cosine t, comma, the integral cosine t plus t sine of t. Okay, let's solve for the first integration. Start with the easiest and with the hardest. So the integral of t squared would just be t cubed over 3. Very easy. Very nice one to start with. Okay. So now we can split this this one integral into 2 separate integrals, right? So we can do the integral of sine of t minus the integral of t cosine of t, and same logic applies to this one right over here. We can do the integral of cosine of t plus the integral of t sine of t. Okay, now we can solve for these individually. This would be much easier than doing it all together. So let's solve for the integral of sine of t we know our integrations. We know that the integral of sine of t would just be negative cosine of t. Very easy, very nice. Okay, minus the integral of t cosine of t. So for this one, we're gonna have to use integration by parts. I do hope you know this. This is basic calculus 2 stuff. So hoping you know it. So we're gonna set u equal to t, dv equal to cosine of t. Our du will obviously be just be dt. And our v, in this case, will be equal to sine of t. Okay, so the integration by parts, let's continue this on the back. Yeah, continue this on the back. It's getting a little crowded here. So let me rewrite what we had here. We had the integral of t cosine t to solve for, and we were going to do integration by parts. We're going to say u equal to t, dv equal to cosine t. Our du would just be equal to dt, and our v will be equal to sine t. So integration of parts, the equation goes uv minus v du. So let's plug and chug. T times sine t minus the integral of sine t dt. Much more doable. So let's solve what we had already solved for an integration of sine of t. So we know this answer is going to be negative cosine t. And since we have two negatives here, this will end up becoming t sine t plus cosine t. Okay, let's rewrite what we already have so we don't get confused. So we have t cubed. Let me just add r of t equal to, let me rewrite that better so everyone can read it. Yeah, r t is equal to vector, we have t cubed over 3, comma, negative cosine t minus t sine t plus cosine t. Okay, and we still need to solve for this, right? So here we have the integral of cosine of t plus the integral of t sine of t. Let us solve for that. So the integral of cosine of t, this is equal to positive sine t. Very easy. Here, let's solve next for the integral of t sine of t. So once again, integration by parts. We're gonna say u equal to t again, making our du equal to dt. And we're gonna set our dv equal to sine t. And our v equivalent to negative cosine of t. Let's use this equation again, and let's plug and chug and solve. So we, once again, are left with negative t cosine t minus the integration of negative cosine t dt. We can move the integration, the negative sign to the outside, making this a positive cosine of t, just so we can better visualize this angle. Maybe that helps someone out. So we know that the integration of a cosine is sine t. So this becomes negative t cosine t plus sine t. Now let's plug it all in and let's circle our answer so we can clearly depict what our RET is equal to. So our RET is equal to t cubed over 3, comma, negative cosine, or in this case, we see that there is going to be 2 negative cosines, right? We distribute the negative. There is going to be 2 negative cosines. So let's just put them together. Just make more room. More room here. Negative 2 cosine of t minus t sine t, comma, and we have our third our third vector value, which you solved for, which is going to be sine of t. We also have another sine of t here. We can make this 2 sine t minus t cosine of t. Let us not forget that this is an indefinite interval. So I happen to just run out of room here. Let me see if I can make this just a tad bit smaller. So this was a negative t cosine t. And on the outside we should have a plus c vector because it's going to be included to all three variables in our vector. So this, and this all have plus c. Okay. Thank you so much.